We've noted before that whenever we have a irrational expression, let's say we have 3 plus 5 times the square root of 2. If we have that in the denominator, we know we have to conjugate that. We can't really divide 1 by this. It doesn't work. We have to, first of all, get rid of the irrational term in this expression by conjugating. That's a practice that we use. So we would change the operation, conjugate it, and then multiply both the numerator and the denominator by this process. Well, there is a faster way to, I'm sorry, I didn't change the sign. That's not good. There's a faster way to conjugate the denominator. And it's always going to be the same answer. It's always going to end up being a squared minus b squared. Regardless of what the sign is here, it's a squared minus b squared because you're going to have a positive times a negative every time. So it's always going to be a negative number here as a result. Okay, regardless of what this is, it's going to be a positive. If this were a negative, it'd be a negative times a positive. So you would always have a negative as your answer. Okay. So that means that if I were to just look at this, I wouldn't really have to do a whole lot of math. I could just simply say, well, 1 times this, that's going to be 3 minus 5 times the square root of 2. And then I could say the square root of 3 is 9 minus, and the square root of 5 is 25 times the square of 5 is 25, and the square of the square root of 2 is 2, so 25 times 2 would be 50. So 9 minus 50 would equal negative 41. That would be my numerator, or my denominator. So then you would realize, of course, because we know how fractions work, one of the rules is you cannot have a negative in the denominator. So you'd multiply the whole thing by negative 1, and then you would end up with negative 3 plus 5 times the square root of 2 over positive 41. And that would be your final answer. Right. So using this, we didn't have to do a whole lot of math. We could do a lot more mental math by having this little shortcut here. This is how you would conjugate an irrational number, right? Conjugate an irrational. I can't spell irrational apparently. Conjugate an irrational number this way. Can we apply that to complex numbers? We can. When we have a complex number, let's say we have 3 plus 5i instead of square root of 2. Well, when we conjugate it, we would be multiplying that times 3 minus 5i. So what we'd end up with would be square root of 3, so that would be 9. And then positive 5 times negative 5, that would be a negative 25. But then we'd have I times I. So that would be from a negative to a positive. So it would be a positive 25. So what we would end up with every single time is a square plus b square whenever we have a complex number that has to be conjugated. So for conjugating complex numbers, we use a squared plus b squared. So to conjugate complex numbers, we use a squared plus b squared. All right, now just to prove my point, I'm going to go ahead and solve this over here the long way, right? 3 minus 5i. Let's put this here. So this would be negative 5 times positive 5, and then I times I. So it would be a negative 25i squared. This would be a negative 15i, positive 15i from here to here, and a positive 9. Those would cancel. And then this ends up canceling to a negative 1. Negative 25 times a negative 1, that becomes a positive 25. So 9 plus 25, which would be 34. And that would be our answer, which that would be 34 also. So you can get to the same place without having to do all this math by just using the same type of format. A square plus b square when you have an I term, and a square minus b square when you have only an irrational term. When you have an irrational and a complex or an imaginary number, then you would use a square plus b square. All right, so let's look at an example problem of this. Let's look at 81.1. So we have 2 plus 3i over 4 minus 2i. So we're going to conjugate this because we want to get rid of the imaginary number. So this is going to be times 4 plus 2i over 4 plus 2i. So we're going to have to do the multiplication for the numerator because they are not conjugates of one another, right? They are different expressions altogether. So we go ahead and do that out. So that would be 6i squared, 4i, 12i, and 8. This I squared becomes a negative 1. So this would become a negative 6. So we would have 16i plus 2. Now that's not standard format. Standard format is always going to be with the I term second. Remember, we've already talked about that. So it would always be written as 2 plus 16i. So that would be our new numerator, 2 plus 16i. Now for our denominator, I'm going to make a prediction. I'm going to predict that we have 16 plus 4. A squared plus b squared. That's 16 plus 4, so our new denominator would be 20. That's my prediction. Let's check it out and make sure. 4 minus 2i, 4 plus 2i. And you might want to do it both ways when you're first doing these types of problems, just so you can make sure you squared these right in your head, right? Or that you did it right. So this would be positive 2i times negative 2i would be a negative 4i squared. This would be 8i, negative 8i, positive 16. These would cancel. This I would become, I squared would be a negative 1. Negative 4 times a negative 1, that's going to be plus 4. That equals 20. So we were right. 16 plus 4 would be 20. We cannot leave it in this format though, because the standard format is always going to be a plus bi. So we have to separate it. We can't leave it as one fraction. We have to have two separate terms, with the complex part being in the second term. So we're going to separate it and say 2 over 20 plus 16 over 20i. We can see that all of these are even and can be reduced. This can be reduced by 2 over 2. So that's going to be 1 over 10 plus, and both of these can be reduced by 4. That's going to be 4 over 5i. And this is the final answer. This is what you would type in. But you could see you could save yourself all of this work by just doing the conjugate of a plus b. Or I'm sorry, a square plus b square, which is what we did here to get the denominator. Let's try another one. 81.2. So here we have 4 minus 2i over 2i minus 3. Well, first of all, this is not in the right format, so it needs to be rewritten in the right format. So let's change this out. 4 minus 2i, and this is a negative 3 plus 2i. Now we have the right form. It always has to be put in standard form first. Now we can conjugate, and this would be times negative 3 minus 2i on the top and on the bottom, the numerator and the denominator. So I'm going to go ahead and predict my denominator, and that is going to be a squared, right? A squared plus b squared. So that's going to be 9. And that is going to be plus 4, 13. That's what I'm predicting my denominator will be, 13. Let me conjugate the numerator. 4 minus 2i, negative 3 minus 2i. That's going to be a negative 2 times negative 2 is going to be a positive 4 times I squared, so that's going to be a negative 4. We have a negative 8i and a positive 6i and a negative 12. So we have negative 2i minus 16 for the numerator. So we have to write that in the right format. So the real number comes first, that's negative 16 minus 2i. So let's go ahead and conjugate the denominator just to double check our prediction. Negative 3 plus 2i, negative 3 minus 2i. Negative times positive is a negative 4 times a negative 1 because of the I squared. It's going to be a positive 4. So negative 2 times negative 3, that's going to be a positive 6i, negative 6i, positive 9. These cancel. These make 13. 13 is the denominator. So we predicted that to be correct by using a squared plus b squared as our format. So we can save ourselves this entire problem right here. We cannot do it if we just use this prediction accurately. However, when you're first doing them, the first couple of problems that you do on your own, use the prediction, use the format, but then do this anyway, just to make sure it's right, just to make sure you got your signs correct, just to make sure that you didn't overlook something, okay? Do that. And then do this, and just to check your work. It's always a good idea to have some way to check your work. And then when you type it in, it's right. But again, we cannot leave this in this format because standard format is A plus BI. They have to be separate terms separated by an operation. So this has to be negative 16 over 13 minus 2i over 13, or what's actually preferred is for this to be 2 over 13i on the side. Kind of the way we do a unit of measure. And that would be the right format and the correct answer. All right, and that's all we have for Lesson 81. If you have any other questions, please feel free to ask. I'll see you in Lesson 82.